Hello everyone, in this video we're going to go with the example review in the part 1 where we check the true and false and multiple choice questions. So first than anything, we're going to go with the true or false questions. Initially, we're just going to take a look at if this is true and false, and then we're going to see why that is the reason. Okay. So, and the first question says, suppose you're approximating the area between a function and the x-axis over the interval 0, 4. So you have a situation where you have the interval 0 to 4. So something like this. And you're checking over a certain function. So what we're doing is we're approximating with rectangles, and the width of each of those rectangles is going to be 0.5. We have 8 rectangles, and so we have 8 rectangles over 0 to 4, and so it says the width of each rectangle is 0.5. So we want to know if that's the case, and that's going to happen because essentially to check these 8 divisions, what we do is we do 4 the endpoint minus 0 the first point, and we divide by 8. This is going to be 4 over 8, and this is going to be 1/2, and that's going to be equals to 0.5, and that's going to be the delta x, which is the length of this piece of the interval. And then after that we can create or approximating rectangles to get the areas. Okay, so this is going to be true. Now, number 2 is if the radius of a circle is increasing as a constant rate, then the area is going to be increasing to a constant rate. And so what happens is that this is going to be false. Why? Because if you remember, the area of a circle is pi r squared. So just that the fact that the radius is increasing at a constant rate is not going to make enough for the radius squared to also go to a constant rate. And the way that we can check that out is to see the differentials. So we do some area 2, which is pi r2 squared, and a1 pi r1 squared. And so when we do the delta a, which is a change between a2 and a1, what that's going to be is pi r2 squared minus pi r1 squared. If we factor the pi, this is pi r2 squared minus r1 squared, and this is pi r2 plus r1, r2 minus r1. So what this means is that this is pi r2 plus r1 delta r. So even if the delta r, if the radius is increased to a constant rate, if this is a constant, this piece is not going to be constant. So that's why we cannot say that this is true. All right, so now question 3 talks about the center of the smallest circle that passes through 2 points is the midpoint of the line segment connecting the 2 points. And that is true. And let me erase here and get something to explain that. So normally we can have a couple points, and we can have in a scenario. Let me do another one. Okay, never mind. Okay, let's assume that you have a couple points that you want to use, and so if you have another circle, any other circle that is not crossing the diameters is going to have this situation. So we have a circle that passes through those 2 points, but those 2 points are not streams, then what's going to happen is that they're very large circles. The best scenario that we can have is if we can have something like, oh, through the particular 2 points that we want, we are using a circle that has that as the extremes. So we can kind of make a diameter between the two points. So this here gives me that diameter, and so this is going to be the smallest circle that is possible that passes through these 2 points. They're polar opposite here in that circle, and we can kind of talk about the radius in here. Okay. So now, since that is what happens, then we can say, okay, so this is going to be the smallest circle, the one that has the diameter. So this here is going to be true. But coming back to the same type of thing, if we're considering that, let's say these 2 points are 1.5, let's say this point here is 1.5, and this point here is 3 minus 3. And we want to know if this is the radius of the smallest circle. We want to calculate the middle point, the center here, we're going to calculate the radius. So because we want the middle, then we want the distance between these 2 things divided by 2. But if you use the distance formula, the distance between these 2 points is the subtraction of the x coordinates and the subtraction of the y coordinate. So 3 minus 1 square plus minus 3 minus 5 square. And so that will be a square root, and 3 minus 1 is 2. 2 square is 2 square is 4, and this is 8. Minus 3 minus 5 is minus 8. Minus 8 square is 64. So this is going to be square root of 68. Now the radius, which is the distance over 2, is going to be square root of 68 over 2, which is not going to be 68. Okay? It's going to be 68 over 2. Don't be confused by the diameter. Okay? Now, so in that scenario, this is false, right? Now, question number 5 is about the vertex form of x squared plus 6x. Remember that this is the vertex form of the completion of the square, is what we use when we want to find out the equation of a circle by completing the square. Remember the process of completing the square, we have something x squared plus bx, and then what we do to complete the square is we add and subtract b divided by 2 square. And so once that we can do that, then we fold this out, and this is x plus b half square minus b half square. Okay, this is the perfect square. Now, in this scenario, let's consider b is going to be 6. So b over 2 is going to be 3. And so if b is equal to 6, this becomes x plus 3 square minus 3 square. So we have that this is true. Now, 6 is about a pizza that sells pizzas of 2 different diameters. One is 8 inches pizza that is cut in 4 slices, and the other one is going to be a 12 inches pizza that is cut on 8 slices. And so we want to know, where did you get more pizza? And they claim that you get more pizza from the 8 inches pizza. Okay, so we can actually find out what's up with that. Let me just remove this, and let's get some pizza here going on. So first we have we gotta remember the difference between diameters, and so let's say first that this is the 8 inches. And so because it's the 8 inches, we're going to split this into 4. So this is what happens when you get the 8 inches. And because this is 8 inches, each of the pieces here on the radius is going to be 4. This is a pizza of radius 4 in terms of the circle, right? So the sum transversal give you 8 inches. Now the 12 inches is going to be a larger pizza. It's going to be something like this. And on the 12 inches pizza, we're going to divide that by 8 instead. So we have a situation like this. And so what we claim is that we get more pizza from the 8 inches. Notice that this is at 12 inches, so this is gonna have here radius 6. Each of this radius is 6. But these two pizzas, they have different areas. So the area of this pizza is pi by 4 square, and the area of this pizza is pi by 6 square. Okay? Because we are getting a slice of this one is pi over 4 square over 4, and the slice over here is pi over 6 square over 8. You see here we divided by 8. Now the funny thing is that this pi 6 square over 8 is going to be actually 14.14, and this one here is going to be 12.57. So even though we're dividing this one for more, this ends up being larger in area for a little bit. And so we get more pizza on the slices from the 12 inches. And so this is false. Now 7 is one that I really don't need a lot of I don't really need a lot of visualization to know that that is true. And is you have a cylinder, so let's say you have this cylinder here, and then you have a cone. And what happens is that they're saying that the cone and the cylinder, they have the same volume. But the thing is, think about it, you have a cylinder here made with this sheet, and you have a cone here. And so if they have the same radius, clearly they're not going to have the same volume. You can fit the cone, if they have the same radius, you can fit the cone inside. And because of the formula, remember, the cone has volume 1/3 of pi r square h, and the cylinder has just pi r square h. So clearly this cylinder is 3 times bigger than, or at least 2 times bigger than the cone. So the only way that the cone gets to have the same volume if the cone is very much larger, and so it has a larger radius. Okay, so this is true. All right, so that's pretty much the end of the true and false questions. Now let's go to the multiple choice. The multiple choice, the first one says the height of a mainsail is 24 feet, and the base is 32 feet. Okay, so if you remember, this mainsail is talking about the practice where we did the reefing. Okay, so we have a sail for a boat that is looking something like the pictures that we have, and so at a certain point, because we want to increase or decrease the speed, we reduce the sail from this to this. And so before we had a height of 24 and 32 here, and now we're going to reduce to just this piece over here. This is going to be the height of my new sail, and this is going to be 18, and here it measures x. So I can make a relationship using similarity of triangles. I can get the small triangle here with the big triangle, and I can make a comparison. I can say x over 32 is the same that 18 to 24. And so there is a way to find out how much x really is from here, and we're going to find out that that is 24. When you multiply that 32 to the other side to 18 and divide by 24, you actually get 24. Okay. So this is going to be answer C. Now, if the main sail here is this kind of a scenario is being reduced, is the area is being reduced by 10%. So in general, I have that the height is being reduced 10%, and the base is being reduced 10% as well. So now we get 90% of the original amount of the height, 90% of the original amount of the base. So the new area of the sail is just going to be 0.9 height, 0.9 base divided by 2. Remember that this is a triangle, and triangles is base by height divided by 2. But now notice that this is just 0.81 times the base, the height, divided by 2, the original. So this is like 0.81 of the old area. Okay, so this says that I still get to keep 81% of the original area. And the answer is B. Now C is just about getting distances. It says which of the following expression is equivalent to the length segment of A. Notice that the segment A is this. I don't need anything else. I don't need to care about this. I just care about the distance between these 2 points. And so the distance between those 2 points here can be calculated as the distance between 0, 2 and 1, 1.73. So that will be 0 minus 1 square plus 2 minus 1.73 square. So that, if you check this out, this is going to be 1 square plus, and this is going to be 0.27 square. So that clearly is this part right here. All right. Now, moving on. Question 4. So in question 4, we have a cylinder called the water dish that is 4 inches deep and has a radius of 3 inches and is being filled at a rate of 3 inches per second. Okay, so probably cannot have a figure to draw it, but it's always good that I get to make my picture so I can have an idea of what's going on. Wish I could draw. Okay, and so now we have water coming in here, and the water is filling in this thing. Now the thing is that the volume, the rate of change of how fast the volume is being filled is given is 3 cubic inches per second. But they want to know what happens after 20 seconds. So the volume after 20 seconds is going to be 3 cubic inches 3 inches cubed per second times 20 seconds. So that's going to be the volume after 20 seconds. And what is that? Well, that's going to be 60 inches cubed, right? Now, but that's just from knowing how fast it's being filled and how much time it happens. But also, we want to know which of these equations could describe the behavior of the depth after this 20 seconds. So the thing is that the volume in terms of the function is of the cylinder is pi r squared times d, because that's by the depth. But since we have information about the radius is actually 3. And I know information about the volume, which is this is 60. Then I have an expression that I can use to solve for d. And so we have that d is going to be equals to 9 pi, sorry, 60 is going to be equals to 9 pi d. And if we look around, we're going to find out that this is this formula. Okay. Now, for question 5, we have that the water is flowing to a conical tank that is 6 feet deep, and it has 4 feet across the top. So this is saying really that I have a situation like this. I have a cone, and I have 4 feet across, which means that over here this is 2, the radius is 2, and some point here I have another radius that I don't know. So my situation in a cross-sectional will be something like this. Here we have 2 from this piece, we have r from this piece. So we can and this is the water that's being filled, a certain h that we don't know, and the total height of the cone is 6. So I can make a relationship between the two triangles. I have r and h, and I have the big one, the big height that is 6, and the radius that is 2. So given that relationship, we have that 2 is to r as h is to 6, or this relationship here. R is to 2 as h is to 6. Okay. Remember, you gotta be consistent. So the larger with the larger, and the shorter with the shorter, or one side of here with one side of here, the other side of here with the other side. Okay, that's how similarity works. You made ratios of 2 corresponding sides, but it gotta be in the same order. Okay. R is to 2 as h is to 6. I could do the other way around, saying h is to 6 as r is to 2, but that will yield exactly the same relationship. Now, the last scenario, we have a frustum, and if you remember what a frustum is essentially you have like a cone, and what's happening is that I remove one of the parts of the cone, like the peak of the cone. We had the peak of the cone over here. And so we remove this piece. So that is the frustum. It's going to be something like this. And so that, by definition, is going to have 2 radius. One radius at the top, one radius at the bottom. And so let's say that we have the big R here and we have the small r here. The formula for the volume of a frustum is pi over 3, which is because this is still a third of the formula of the cone, by the height, whatever that is, and then by r squared plus r times the small r squared. So this is like a situation that is given here with the different radius. Now let's assume that we have information in one of the radius. Let's assume that we have information about the big radius, and the big radius is 1. So we're gonna say, well, this is pi over 3. Oh, and I have that the height is 9 inches, so I can replace that here. And I get, replacing big R by 1, that this is 1 plus R squared. And so I have that information about the frustum. What else do we have about the frustum? Oh, we have that the volume is 21 pi. So I can replace that here. And that is going to be 21 pi. Now, I get to cancel some things. The pi can be canceled with this. The 9 and the 3 can be canceled. It says I'm going to get just 3. And now, of course, I can divide this 21 by 3 equals to this. And this is just 7, right? 7 by 3 is 21. Now, so at the end, I can move the 7 to the other side, and this is going to be minus 7. So 1 minus 7 is minus 6. So minus 6 plus r squared. So we'll take a look at this. R squared plus r minus 6. That's answer A. Okay. And so that's the end of the multiple choice questions and the true and false question.